Hey class, Mrs. Anderson here. I hope you've had a good day, or a good week, I mean. All right, today we're going to do different types of solutions, and I'm really going to blow your mind on this one, I think. Maybe not, but it should be fun, and I can't wait to talk about it with you when I return. Today we're going to talk about like the different types of solutions, if it has one solution, no solution, or infinite solutions. So here's your warm-up problems. Hopefully you had a chance to work on them. If not, do them with me now. So here we have w plus 3 equals negative 4. So we're going to start by solving this. We want to do the inverse of plus 3, which would be minus 3. So it's a pretty simple one-step equation. The hard part comes in right here when we have negative 4 and negative 3. We have to remember when we have the signs are the same and we're adding or subtracting like this, we keep the sign and we just add them up. So 4 plus 3 is negative 7. Because negative 4 minus 3 is the same thing as negative 4 plus negative 3. So that's 4 negatives and 3 more negatives. So negative 7. All right, negative 5 equals n divided by 4. That's what this fraction bar means. So the inverse of dividing by 4 is multiplying by 4. So to get rid of the divide by 4, we multiply. So then on the left side here, 4 times negative 5 will be negative 20. And then we just left with n. So n equals negative 20. This is a review from variables on both sides of the equation. So in these types of problems, we have x's on either side. So we want to get the x's all on one side. And so I usually move my x's from the right to the left. So this is a 1x here and it's positive. So I'm going to start by subtracting x. And then just remembering that that means I'm subtracting one of those x's. So 3x's minus 1x gives me 2x's. And then I have minus 3. And then x minus x is 0, and I get 7. Once I get my variables on one side of the equation, I'm looking to isolate that x term. So I want to work with this negative 3. The inverse of minus 3 is plus 3. And I get 2x equals 7 plus 3 is 10. And if I have 2x equals 10, my last step then is to divide both sides by 2. And I get x equals 5. And the last warm-up was another one with variables on both sides. And so if I have variables on either side of the equal, I need to move my variable terms to one side. So I'm going to start by this negative 4a, and so I'm going to do plus 4a. Make sure you bring the variable with it, and then make sure you line that up with the like term on the other side. So this 2 had an a, so the 4a is going to go with the 2a. The a is going to come along. So I'm going to have 2 a's plus 4 a's is going to be 6 a's. I'm going to bring that positive 2 down. This equals 0, so all I have left on the right is 32. Now that I have all my variables on one side, I'm going to subtract 2 to get the 6a by itself. So the inverse of plus 2. 6a equals 30. And that's 6 times a equals 30. So you might be thinking 6 times 5 is 30, and you'd be right because you divide by 6. And we get a equals 30 divided by 6, which is 5. I ran out of room there again. Might have to space those out a little bit more next year. Okay, so those were some quick warm-up problems. Now we're going to talk about different types of solutions. So a solution is a value that we can substitute for a variable to make the equation true. And that's the whole point, that we end up getting, like in the last video I did, we ended up plugging it in and we got 11 equals 11, which is a true statement. And when that happens, it means that that value for the variable was our solution, because it made the equation equal, the same number on both sides. So we're going to consider the warm-up problems, and how many solutions did we have in each one? We had one solution for each. And so for linear equations, it's common to get one answer, but that's not always the case. So we're going to see what happens when we see a couple different situations. So here's our first example. Notice that we have variables on both sides. So our goal is to get all of the variables on one side. So we'll start with moving them from the right to the left. We have minus w, or a positive w, so we're going to minus w on both sides. So we're going to make sure we line those up. We have a 1w minus a 1w on the right. That gives me 0. I'm left with negative 4. On the left, I have 1w minus 1w. That's 0 again. So I get just 0 plus 3. So I end up with 3 equals negative 4. Because both of my w terms on both sides, since they were the same number of w's on either side, when I subtracted them, there was no w's left. So I was left with 3 equals 4. Well, that's not a true statement. 3 is not equal to negative 4. And so when we solve an equation and our solution is false, like we get this, where we get our variables cancel and we get a false statement, the equation has no solutions. And that means that there is no value for the variable that would make this equation true. Like if we think back up to w plus 3 equals w minus 4. Let's try 10. What if w equaled 10? Well, 10 plus 3 is 13, and 10 minus 4 is 6. And we could try any combination of w's. We could plug in 100. We could plug in negative 10. We could plug in 15. But because each of the w's were the same, if you add 3 from one side and subtract 4 from the other, this part will never be true. And so this equation that we started out with has no solutions. There's no value for w, in which case it would make that equation true. So let's look at a couple more examples. Okay, this one is a variables on each side, but we have distributive property first. We're going to start with that. So 3 times n is 3n, and 3 times negative 1 is negative 3. And then we have 3n minus 5 on the other side. Now we have variables on either side of the equation, and so we want to get the variables all on one side. So positive 3n on the right, so I'm going to subtract 3n on both sides. Now you might notice again 3n minus 3n is 0, so I just get negative 3 left here, and then 3n minus 3n is 0 here, so I get negative 5. And then negative 3 equals negative 5 is false, and so that means that there is no solution. There is no value in which n, no number for n that you could plug in that would make this equal. And so it's no solution. All right, I'll show you one more. So here we have 2a plus 2 equals 1/2 times this quantity. So first start with the distributive property. You're going to end up multiplying 4 by 1/2. So you can put that over 1 if you want. And that's going to be 4 over 2a plus 32 over 2. because you're going to multiply the numerators and then the denominators. So that's going to be 2a plus 16. And then on this side, you still have 2a plus 2. You might notice right away that you have the same values for a on either side, but different values for the constants. So that's a key indication that this is no solution, because when you go to solve, you subtract your a values to the other side, and they cancel or equal 0 on both sides. So then you're left with 2 equal to 16, which is not true. So this is the not equal symbol, which means we had, again, no solution. So far we've seen equations that have one answer, one solution. We get like x equals 7. And then we have no solution where there's no value, no number from negative infinity to infinity that would work to make this equation true. And then we have a situation where this happens. So we have w plus 3 equals w plus 3. And if we think about it, the equations are equal on both sides. If you wanted to solve for w, you would start the same way. You have a positive w, so I would subtract w from both sides. Well, w minus w is 0, so I get 3. And w minus w here is 0, so I get 3. This time, 3 does equal 3. So my equation is true. And when you solve an equation and both sides are the same, the equation has what we call infinite solutions. And sometimes to make it easier, instead of writing infinite, we just say many, because infinite is a hard word to remember and it is kind of a hard word to spell. So sometimes we'll just say it has many solutions, but really we mean infinite, like from negative infinity to positive infinity. Pick a number, plug it in, it will work. Think back to w plus 3 equals w plus 3. And think back to when we picked 10. 10 plus 3 equals 13, and 10 plus 3 equals 13. So that's one solution. You could do negative 999 plus 3, and then negative 999 plus 3. And you would get the same answer because it's the same. Both w's are the same. So negative 996 equals negative 996. So you could literally pick any value for w and it would be true statement. So sometimes it's obvious when the equations are the same, like it was here. W plus 3 is equal to w plus 3, but not always. Sometimes they look different, but then they end up being equal. So in this one, we have a distributive property and then an equation. So if we distribute, we have 3 times n, which is 3n, and then 3 times negative 1, which is negative 3. And then we still have this 3n minus 3. So you might be able to tell right away that these are the same equation on the left and the right. When that happens, that means it is infinite solutions. It has to be the exact same. So both have positive 3n and negative 3. Positive 3n and negative 3. It would not work if it was even slightly different, like positive 3 and negative 3. Because then you would subtract 3n on both sides, and you get negative 3 equals negative 3, which is always true, so we would say many solutions. Here's one more, many solutions. So these are actually the same equation over here, but they don't look the same right away. And so we can start by solving. We can distribute that 1/2 through. So you're going to get 4 times 1 and 2 times 1. So you get 4 over 1a, or I'm sorry, 4 over 2a, or 1/2 of 4, which is 2a, and then times by 4 again. So you're going to get 2a plus 2. And that's the same thing you have on this side now, in which case it would be many solutions, because they are exactly the same on both sides. All right, let's try just a couple more. We're going to determine the number of solutions, and if it has one, we're going to find it. So looking at our first example, these equations appear to be different. So it's possible that it would have one solution. But I need to distribute first. So 2w, 2 times w is 2w, and then 2 times -3 would be -6. On the right, I have a w minus 4. So I notice right away that I have different values, different numbers of w. So that means there should be one solution. So I can finish solving this by getting all my w's on one side. So I'm going to move it from the right to the left. I have a 1w, so I'm going to minus w. Line it up with the w term on the left, the 2w. Remember that that's a 1w, so 2w minus 1w is 1w, or just w. Minus 6 equals, over here you have -4 left. And then add 6. And we're going to get 1w, or w, equals -4 and +6 have different signs. Find the difference between them, so +2. And so we knew it was one solution because essentially the equations were different. W values. So we had 2 w's and 1 w, which led me to believe that I would have at least one solution. All right, let's look at this one. We have 2 distributive properties here. So I'm going to start by multiplying the 2 in. 2 times 2a is 4a. 2 times 2 is 4. Notice I couldn't really tell just by looking at it right away that these equations are different or similar. So I have to do the distributive property first. Then 1/2 times 8a, that's going to be 8 over 1 times 1 over 2 is going to be 8 over 2, so 4a. And then you have again an 8 times a 1/2, so 4. Now when you look here, these equations are exactly the same. If you were to subtract the 4a from both sides, you would get 4 equals 4. If you subtracted 4 from both sides, you would get 0 equals 0. So when the equations are exactly the same, that means that there are many solutions. Infinitely many solutions. So many solutions. Essentially a equals 8 here. So we would say that the equations were equal in the sense that they were the same equation. So all equations that we're dealing with include an equal sign, but when I say that they were equal, I mean that they were the same exact equation on the left side and the right side. Okay, it's a little hard to tell because of the distributive property, so we'll start by distributing. We have some like terms too. So I'm going to distribute this 5 times x, and 5 times -4 is -20. And then on the left side, I notice I have two x terms. I have 3x minus 2x, which leaves me with a 1x. So now I have 1x equals 5x minus 20. So I should have more than one solution because I have different values for x. On this side I have 1, and on this side I have 5. So I'm going to start by subtracting because I have positive 5. I'm going to get all my x's on one side. So I'm going to start by subtracting 5 x's on both sides. And 1 minus 5 is -4x. 1 is smaller than 5, so I'm going to end up with a negative or positive 1 and then -5. They're different signs, so find the difference between them. There's -4 left because these equal 0. And -5 and -5 is 0, and then -20 here. Then divide by -4 on both sides to get the x by itself. Then when you divide a negative, divided by a negative is a positive. So we knew that we had one solution, and it was basically because our equations on each side had different x's, if that makes sense. Like the variable number, the number of x's on either side. So we started with 1 and 5. So that gave me the notion that there was at least one solution. Okay, last one. Okay, so first I noticed that I have some like terms over here. So I'm probably going to start by combining those. So on the left side, I can just leave it as -5 plus x. Over here, I have 3x minus 2x. Well, 3 minus 2 is 1x, and then I have -7 still. And then you might say to yourself, well, I know it's going to be no solution now because I have an x and an x, and then the numbers with it are not the same. I have a -5 and a -7. This really is the same thing as -5 plus 1x and -7 plus 1x if you rewrote that, or 1x minus 7 and 1x minus 5. So this is a 1x, they're both 1x's, but -5 and -7 are not equal. So when you subtract the 1x from both sides, you end up with -5 equals -7, which is not true, not equal. And so this one has no solutions, or no solution. And it's because the equations had the same number of x's, but different constants. Like the constant values, the 5 and the 7 were different, but the x's were the same. So that means no solution. And they were on opposite sides of the equal, so that's key as well. All right, if I can remember, this was 5.3D. Sorry for scrolling around here. So the homework that goes with this is 5.3D. Please give that a shot. And I look forward to seeing you all soon. I hope you're having a wonderful week. Thank you for listening. Hopefully I kept this short and it was okay to follow.